Alright, now we're going to begin lesson 107, Measuring Angles Part 2, and our objectives in this lesson are to define and identify an angle, the parts of an angle, and angle pairs. We're going to measure and classify angles, and then we're going to identify and use angle addition postulate and the angle congruence postulate and the linear pair postulate. Some new terms that may not be so new to you, maybe review, are adjacent angles, complementary angles, a linear pair, and supplementary angles. Let's get kicked off with our postulates. First we have postulate 1.6, which is the angle addition postulate. It says if point D lies in the interior of angle ABC, then the measure of angle ABD plus the measure of angle DBC equal the measure of angle ABC. So this is better visually. If you look at this, you got angle ABD, and then you're going to add it to the measure of angle DBC, and when you add those together you're going to get the sum, which is the measure of angle ABC. Then you have postulate 1.7, which is the angle congruence postulate, and it says if two angles have the same measure as measured by a protractor, then the angles are congruent. Also, if two angles are congruent, then they have the same measure as measured by a protractor. Now, don't let these just boggle your mind, because if you think back to the segment addition postulate and the segment congruence postulate, they're exactly the same, except now we're dealing with angles instead of segments. We're going to kick off this by looking at pairs of angles. There are certain pairs that have special names, such as adjacent angles. Those are two angles that lie on the same plane, have a common vertex and a common side. So here's some examples of what adjacent angles look like, and I've also supplied you with some non-examples, things that aren't adjacent. Another pair that we're going to look at a little bit more in a minute is a linear pair, and it's a pair of adjacent angles with non-common sides that are opposite rays. Here's your non-common sides, and if you look, it's a straight line, and you put point E there in the middle, and that makes it opposite rays. And here's a non-example of a linear pair. So let's look. Pairs of supplementary angles. Okay, here our focus here isn't on the supplementary part, it's on the linear pair, and there's the definition of a linear pair again. But let's look at the pictures. This right here is a linear pair, and if you look, they're also supplementary, because linear pairs will always add up to 180 degrees. Got 110 plus 70, that's going to equal 180. But over here, if they were attached, they would be a linear pair. You got two right angles that are both 90 degrees, and when you add them up, they're 180, so that makes them supplementary, but they're not a linear pair. So let's look at postulate 1.8, the linear pair postulate. It says if two angles form a linear pair, then they are supplementary angles. That's kind of what I told you up here. If it's a linear pair, they're always supplementary. Now we're going to look at complementary angles. Those are two angles with measures that have a sum of 90 degrees. And it doesn't matter if they're adjacent or not, as you can see in this picture over here. Right here we have a 90-degree angle. Well, we know the sum of 1 and 2, angles 1 and 2, are going to add up to 90 degrees, so it makes them complementary. If you look over here, you got angle Q and angle Y. Angle Q is 50, angle Y is 40. You add those together, you're going to get 90. So angle Q and angle Y are both complementary. When you have supplementary angles, those are two angles with measures that always have the sum of 180. If you look here, you've got a linear pair, and they're always going to add up to 180. Then over here, they're not adjacent, they're separated, angle M and angle N. Angle M is 80, angle N is 100, and of course the sum of those is 180, so that makes them supplementary as well. Now if you look in your text, it says an easy way to remember this is that C comes before S in the alphabet. Well, when you're looking at the numbers, 90 comes before 180. Remember, complementary, the sum is 90. Supplementary, the sum is 180. So that's an easy way to remember who's who. Now let's look at some examples. Now what I want you to notice first is that they gave us some information. They told us the measure of angle FEA equals 20 degrees and the measure of angle BED equals 45 degrees. So I went ahead and labeled those so I could tell which angle was which. Then in part A, they told me to find the measure of DEA. Well, I know that the measure of DEA, this angle right here, and matter of fact, let's mark it. You know, I like to mark them. There's they want me to find the measure of angle DEA. Well, I know that the measure of DEF, let me get my pointer, DEF, I know that measure right there is going to be 90 degrees. So, but I also know that the measure of DEA is going to equal the measure of DEF minus the measure of angle FEA. So I just plug in the numbers I know. I know that DEA is my unknown. I know that DEF is 90, and I know the measure of FEA is 20. So when you plug those in, it's easy to tell. Well, I kind of got these backwards, didn't I? I put the numbers backwards. But you're going to have 90 degrees minus 20 degrees is going to equal 70 degrees. So we know that DEA is going to be 70 degrees. Now they want me to find the measure of angle BEC. So I like to label which one I'm looking for. There's BEC. Now here again, we know that DEC right here is 90 degrees. Well, they've called it CED, but either way. And then we are looking for BEC. We know the measure of BED is 45 degrees. So let's plug those in. I got these numbers backwards too. But you do know that 90 minus 45 degrees is going to give you 45 degrees. So the measure of BEC is going to be 45 degrees. The next one is asking me for the measure of AEC. So I'm going to mark this AEC. And ooh, that's an obtuse angle. So if I look at this, I know that AEC is what I'm looking for. I know that the measure of CED right here, CED, is going to be 90 degrees. And I know the measure of DEA is 70 degrees. So I'm just going to plug in those numbers. And look, I actually got them plugged in correctly. CED is 90, DEA is 70. You add those together, you're going to get 160. This next one is asking me for the measure of FEB. So let me mark that. Oops, forgot to stop it. FEB, right there. That's an obtuse angle. And if you look at your numbers that are already up there, you know that, let me see how they name this, FED is 90 degrees. You know that BED is 45 degrees. So you're going to be plugging those numbers in to figure out what FEB is. And there you go. FED is 90, BED is 45. You add them together, you get 135 degrees. All of these are representative of the angle addition postulate. Alright, on this next example it says use the figure given and information to find the missing angle measure. Notice in part A they tell me that angle ADC is 43 degrees and angle BDA is 79 degrees, and I've gone ahead and labeled those in here. Now what I do know, well, they want me to find the measure of BDC. So BDC. So it's pretty cut and dry. I can use the angle addition postulate here to get my answer. So I know that BDC is going to equal the measure of ADC plus the measure of BDA. So let's plug those numbers in. And ADC plus BDA, you're going to get a measure of 122 degrees. This next question's sort of different. Same thing, you're still using the segment addition postulate, you're just going about it a different way. They told me that CAB is 73 degrees. So if I go CAB, it's kind of hard to label that as 73 degrees when I've got this line splitting it up. So I didn't label anything there, but I did label angle BAD as 44 degrees. Now this is still going to work the same way. They want to know the measure of DAC. So let's mark that, DAC. Now, let me get my pointer. They told me to find the measure of DAC, so I'm going to plug in the measure of CAB, which is 73, and the measure of BAD, which is 44, to get my answer. And there you go. The measure of DAC is going to be 29 degrees. Now, I threw in this next example because I wanted you to refresh your mind on algebra, because I know that's all your favorite subject, and we're going to use a lot of algebra and geometry. So they give me this information up here. They said if angle ACB is the difference of 6y and 7, and DCA is the difference of 8y and 1, then find the measure of each angle. Well, the first one we're looking for is the measure of angle ACB. So let's look. ACB. This is the one we're looking for right now. Well, first we got to find out what the measure of ACB is. We've got to figure out what y is. Well, if you look, you can tell that this angle right here, BCD, is a right angle. Well, I know if I add these two angles right here together and make them equal 90, then I can solve for y to figure out what y is. So that's what we're going to do. Notice how I've set it up. Measure of angle ACB plus the measure of DCA equals 90. Then I plugged in the expressions that I was given. My next step is it's all algebra from here on. I got to combine my like terms. 6y and 8y is 14y. Negative 7 and negative 1 is negative 8. And then you know the next step in algebra is you're going to add that 8 to both sides. So you got 14y equals 98. And then you're going to divide both sides by 14 and discover that y equals 7. So all you have to do now is plug 7 into the expression for the measure of angle ACB. And that's what we did right here. We took 6y minus 7. We plugged in what y equaled, which was also 7. That gave us 42 minus 7. So the measure of angle ACB is going to be 35 degrees. Now part B is a walk in the park because we've already found out that y equals 7. So all we have to do is plug that 7 into the expression. We get 8 times 7 is 56 minus 1. And so the measure of angle DCA is 45. So if you went back and you added up 35 and 55, you're going to get 90. And that's your proof that your problem is done correctly. Here's some of the links that you're going to find in doc sharing that will help you with anything that we've studied about measuring angles pretty much. Especially, well, it's not here like I thought it was. There is a video in there that teaches you how to use a protractor. I would highly suggest you use that one. A lot of students have problems with that. But it looks here at Khan Academy that they're also teaching that same concept to you, so it might be helpful to watch those videos. In summary, we've learned that angles are said to be congruent if their measures are equal. We learned about adjacent angles and the definition. We've learned about complementary angles and supplementary angles, and we also talked about linear pairs. What you should be doing after you've watched this video is going through the lesson in the LMS, reading pages 11 through 14 in the reference guide if you haven't already, practicing with these problems, and you know there are answer keys to the problem sets, so these are self-check problems. You don't have to turn them in. And please, if you don't understand anything, contact me or attend TOGA if you have questions before you complete quiz 1.07, because there are no retakes or corrections for the quizzes. And then, last but not least, make note of any general questions you may have so you can ask them in CC on Thursday. And that's the end of lesson 1.07.